Welcome to Haes Technologies Technical Support videos. In this video, we will explain how to install the PIR/BMS card onto the MZAOV range of panels. The new card is broken down into two distinct areas. At the top there is the rain sensor, BMS and PIR connections for Zone 1, and below are the PIR and BMS sensor settings for Zone 2. The rain setting is common to both areas. The PIR/BMS card will be piggybacked on top of the first zone card. If you have additional zone cards and they require the PIR/BMS cards, again they'll have their own card fitted in this area, similar to the Zone 1 card. It is possible to add a PIR/BMS card to each zone card. Step 1 is to install the 4 nylon pillars supplied, and they'll pop into the 4 holes provided. It should be said at this point that the power to the panel should be switched off. The next step is to install the ribbon cable between the old zone card, the original zone card, up to the new PIR card as shown here. The 10-way header on the PIR card and a 10-way header on the existing zone card. The PIR/BMS card can now be pushed down onto the 4 nylon pillars and fixed. The panel can now be powered back up again. At this stage, the panel will not recognise and the card will be non-functional until programmed to be told to do so. The next step is to go into the config menu on the panel, then choose the circuit option. Within this option, there is the ability to enable and disable the PIR and the rain circuit sensor on the new card. So these, obviously, if you need to use these must be set to enabled for both options. Next, go into devices, then go to the vent option. And within this option, we can tell each vent area at the top here. So we can select the vent number 1, vent 2, vent 3, vent 4, vent 5, as many as you have there. And we can tell the vents what they're going to be controlled by. And here again, we can break that down into a vent area where we can say use rain control, yes or no, use PIR control, yes or no, use BMS control, yes or no. Again, depending, as long as these cards are fitted to the zone area you're requesting. Once set, the card will become fully functional. The PIR inputs can be connected to any typical type PIR detector. They require normally closed alarm contacts and tamper contacts. The PIR will require a 12-volt supply, which is also available on the plug-in card. And the device will require a 10K resistor to trigger with a 6K end of line. Monitoring current is limited to 14 milliamps. It's unfused. When operated, the PIR device prevents the vent from closing to guard against entrapment injury. The PIR should be mounted in accordance with the manufacturer's instructions to detect any presence within the vicinity of the entrapment risk, i.e. the window opening and closing. The rain sensor input can be connected to any suitable wind or rain sensor, and it will need a closing contact alarm signal, and often will require 24 volts, which can be taken from the panel. The input will require a 2K7 resistance to trigger it, with a 6K8 end of line. Again, monitoring current is limited to 14 milliamps. Up to 4 rain sensors can be installed on the system, any one of which can close all manually open vents, but will never override an alarm signal input. The BMS1 and BMS2 building management circuits used to connect to a building management system control interface using 0 to 10 volt proportional control signals. There is a 0 volt common 0 volt output. This is 0 volt common with reference for the 0 to 1 to 10 input and output control signals. The BMS in signal. This is a positional voltage input that accepts 0 to 10 volts DC, signaling 1 volt steps that will open the windows 10% of the motor runtime. i.e. the first 1 volt will open up the windows 10%, 2 volts will open up the window 20%, 3 volts will open the window up 30%. This is a percentage of the runtime set. Remembering the default is 60 seconds, so 10% will equal 6 seconds of runtime. This can be adjusted in the vent settings of the panel itself. Max input is 10 volts DC with 75k impedance. The output terminals provide a positional voltage output. Again, this output represents the position of the vent in 10% steps of motor runtime. It provides feedback of the 0 to 10 volt input status and vent positional information. Max output is 10 volts at 2 milliamps, maximum 20k load and 680 ohms impedance. Thank you for watching. For more videos, please visit our website at www.haes-tech.com.